Newton's three laws of motion, three laws laid down flat, rely on these notions, I'll keep it compact. The first law, when an object keeps its own motion unless it is forcibly moved in the balance unbroken. And the second law is kind of hard to be spoken. It's an equation for the force of an object, mass times acceleration. And the third law, when two objects interact, two forces are applied to the other with equal contact. On a completely different subject, I'm going to talk about waves, the direction, the flow, and the rhythms they take. Specifically, the waves of light. The list goes on because what a sight. First, I want to talk about how waves work so that when I'm explaining it to you, you don't go berserk. A wave is like a disturbance in the force, a transfer of energy. Two kinds, of course. Mechanical, the transfer of energy through matter. It needs a medium to travel through, unlike the latter, which is electromagnetic. Energy through a field. It does not need a medium to halt it or yield. A transverse wave is what we'll talk about today, because those are the kinds that give light a say. The longer a wave, the shorter its frequency, meaning the troughs and crests come together less frequently. When you have a shorter wave, the distance is equally closer together with chances of higher energy, which is light, made up of photons. They have no mass but momentum. They travel in straight lines that are rays. What we can see with our eyes, reflected, transmitted, absorbed, can be disguised with different colored lights that I will explain later, and I will serve as your physics translator. But before we go on with that, I'm going to circle back to my boy Newton's three facts. Inertia, motion, action, and reaction are all changed by a force of interaction. An object in motion will stay in motion based on the notion that two objects at the same speed and direction will continue at this rate until a balanced force is broken. F equals m times a. When a constant force acts on a massive body, it causes it to accelerate, to change its velocity, and the equation is inverse if that piques your curiosity. Every action has an equal opposite reaction force, a push or pull, when two bodies interact. Depending on the mass of your two objects, it will impact which one of them falls back. And now for a hack for some light waves facts. Roy G. Biv seeing white or black. You're gonna add together or subtract to see which one you lack. Red is the start of the color sequence. It's the color with the lowest frequency. Then it goes up like a rainbow. Orange, yellow, green, blue, and indigo. Last one's violet, kinda like UV rays, but we can talk about that one another one of these days. Physics is fun. This is no phase. I'm glad I made this instead of writing one of those essays. Now you can look back to Newton's facts and light waves. I hope I didn't miss anything. Have a good day!
She gets it.